It is necessary to use weatherproof boxes, vapor-tight light fixtures, cell-tight and compression electrical metallic tubing, or aimed fittings and coolers to ensure safety and maintain the integrity of the enclosure. Coolers are often exposed to moisture and outdoor conditions, such as rain, snow, and humidity. Weatherproof boxes and vapor-tight light fixtures are designed to resist moisture ingress, preventing electrical hazards and damage to components. Condensation can occur inside a cooler due to temperature fluctuations. Vapor-tight light fixtures and cell-tight fittings prevent moisture vapor from entering the enclosure, protecting electrical components from corrosion and insulation degradation. Compression EMT fittings create a tight seal around the conduit, preventing moisture, dust, and other contaminants from entering the electrical system. This ensures electrical safety by preventing short circuits and electrical shocks. In many jurisdictions, electrical codes require the use of weatherproof enclosures and vapor barriers in locations exposed to moisture or outdoor conditions. Failure to comply with these codes can result in safety violations and fines. Using appropriate fittings and fixtures helps protect electrical components from damage caused by moisture, condensation, and environmental factors. This extends the lifespan of the equipment and reduces maintenance costs. By using weatherproof boxes, vapor-tight light fixtures, cell-tight and compression EMT fittings and coolers, you ensure a safe and code-compliant installation that protects electrical equipment, prevents accidents, and maintains the integrity of the enclosure. Weather resistance is a key factor. Coolers are frequently subjected to moist environments and external elements such as rain, snow, and humidity. Weatherproof boxes and vapor-tight light fixtures are specifically engineered to prevent moisture from entering, thereby mitigating electrical hazards and safeguarding the integrity of the components. Vapor resistance is equally important. The potential for condensation to develop within a cooler, stemming from temperature variations, necessitates the use of vapor-tight light fixtures and cell-tight fittings. These components effectively block moisture vapor from infiltrating the enclosure, thus shielding electrical components against corrosion and the degradation of insulation. Electrical safety is paramount. The utilization of compression EMT fittings ensures a reverse seal around the conduit, effectively preventing the ingress of moisture, dust, and other contaminants into the electrical system. This measure is crucial for maintaining electrical safety as it mitigates the risk of short circuits and electrical shocks. Code compliance is a non-negotiable aspect. Numerous jurisdictions mandate the use of weatherproof enclosures and vapor barriers in areas prone to moisture or outdoor exposure. Non-compliance with these regulations can lead to safety violations and the imposition of financial penalties. Equipment protection is another significant benefit. Employing the appropriate fittings and fixtures plays a pivotal role in shielding electrical components from the detrimental effects of moisture, condensation, and environmental factors. This proactive approach extends the operational lifespan of the equipment and curtails maintenance expenses. Firstly, consider the environment. Coolers inherently present a challenging environment for electrical components due to the presence of moisture and temperature variations. Secondly, understand the function of weatherproof components. Weatherproof boxes and vapor-tight light fixtures are designed to withstand these conditions, preventing water ingress and protecting the electrical connections and components inside. Thirdly, recognize the importance of vapor barriers. Condensation is a common occurrence in coolers, and vapor-tight fittings and fixtures like cell-tight help to prevent moisture from entering the electrical system, which can lead to corrosion and failure. Fourthly, appreciate the role of compression fittings. Compression EMT fittings create a tight, secure connection that prevents moisture and contaminants from entering the conduit system, ensuring a reliable and safe electrical pathway. Fifthly, consider code compliance. Electrical codes often mandate the use of weatherproof or vapor-tight enclosures and fittings in damp or wet locations, such as coolers, to ensure safety and prevent electrical hazards. Sixthly, think about long-term reliability. Using the appropriate components in coolers helps to extend the lifespan of the electrical system and reduce the need for frequent maintenance and repairs. Seventhly, prioritize safety. The primary reason for using weatherproof and vapor-tight components in coolers is to ensure the safety of personnel and prevent electrical hazards such as shocks or fires. 8thly, remember proper installation techniques. Even the best components will not provide adequate protection if they are not installed correctly, so it's crucial to follow manufacturers' instructions and best practices for installation. 9thly, consider the specific application. The specific requirements for weatherproof and vapor-tight components may vary depending on the size and type of cooler, as well as the electrical load and environmental conditions. 10thly, consult with a qualified electrician. If you are unsure about the appropriate components or installation techniques for electrical systems and coolers, consult with a qualified electrician who has experience with these types of installations. The selection and installation of electrical components in coolers should always prioritize safety and compliance with relevant electrical codes and standards. Weatherproof boxes are specifically designed to protect electrical connections from the elements, preventing water from entering and causing corrosion or short circuits. Vapor-tight light fixtures are sealed to prevent moisture from entering the fixture and damaging the lamp or electrical components inside. Cell-tight is a flexible conduit that is designed to be liquid-tight, preventing moisture from entering the conduit system. Compression ENT fittings provide a secure, watertight connection between the conduit and the electrical box or enclosure. The combination of these components ensures that the electrical system in a cooler is protected from moisture and condensation, which can cause electrical hazards and equipment failure. Failing to use these components can lead to a variety of problems, including electrical shocks, fires, and equipment damage. In addition, it can also result in code violations and fines. Therefore, it is always recommended to use weatherproof boxes, vapor-tight light fixtures, cell-tight, and compression ENT fittings and coolers to ensure safety, reliability, and code compliance. The National Electrical Code, or NEC, provides guidelines for electrical installations, including those in damp or wet locations like coolers. It is essential to consult the NEC and local electrical codes to ensure compliance. Some relevant sections of the NEC might include Article 100, which defines damp and wet locations, Article 300, which covers wiring methods, Article 314, which addresses junction boxes, pull boxes, and hand-hole enclosures, Article 410, which pertains to luminaires, lamp holders, and lamps, and Article 500 and 505, which deal with hazardous locations, though these may not always apply to typical coolers. The definitions of damp and wet locations in Article 100 are critical for determining the appropriate types of enclosures and wiring methods. Damp locations are defined as locations protected from weather and not subject to saturation with water or other liquids, but subject to moderate degrees of moisture. Wet locations are defined as locations subject to saturation with water or other liquids, such as vehicle washing areas, and locations exposed to weather and unprotected. For coolers, the interior is generally considered a damp location due to condensation, while areas directly exposed to water, such as during cleaning, might be considered wet locations. Article 300 provides general requirements for wiring methods, including protection against physical damage, corrosion, and moisture. It specifies that wiring methods and equipment used in damp or wet locations must be identified for use in such environments. Article 314 covers the installation of boxes and enclosures, which are used to protect electrical connections. It requires that boxes and enclosures installed in damp or wet locations be weatherproof or raintight, and that they be installed in a manner that prevents moisture from entering the enclosure. Article 410 addresses the installation of lighting fixtures. It requires that fixtures installed in damp or wet locations be listed for use in such locations and that they be installed in a manner that prevents moisture from entering the fixture. Using vapor-tight fixtures helps to meet these requirements. Articles 500 through 505 address hazardous locations, which are areas where flammable gases, vapors, or dust may be present. While typical coolers are not considered hazardous locations, some coolers may contain flammable materials, such as certain refrigerants, which could make them hazardous locations. In such cases, additional requirements would apply. The selection of appropriate wiring methods is also critical for ensuring safety and compliance in coolers. Some common wiring methods used in coolers include electrical metallic tubing, or EMT, with compression fittings, liquid-tight flexible metal conduit, or LFMC, with liquid-tight fittings, and non-metallic conduit, or PVC, with appropriate fittings. EMT is a rigid metal conduit that provides excellent protection against physical damage. Compression fittings are used to connect EMT to boxes and enclosures, and they provide a watertight seal when properly installed. LFMC is a flexible metal conduit that is designed to be liquid-tight. Liquid-tight fittings are used to connect LFMC to boxes and enclosures, and they provide a watertight seal. PVC is a non-metallic conduit that is resistant to corrosion and moisture. PVC fittings are used to connect PVC to boxes and enclosures, and they provide a watertight seal when properly installed. The choice of wiring method will depend on the specific application and the environmental conditions. In general, EMT is a good choice for areas where physical protection is required, while LFMC is a good choice for areas where flexibility is needed. PVC may be a good choice for areas where corrosion resistance is important. It is important to ensure that all wiring methods and fittings are listed for use in damp or wet locations and that they are installed in accordance with the NEC and local electrical codes. Proper grounding is also essential for ensuring safety in coolers. All electrical equipment in coolers must be properly grounded to prevent electrical shock hazards. Grounding can be achieved by using a grounding conductor in the wiring system and by connecting all metal enclosures to ground. The grounding conductor must be sized in accordance with the NEC and must be properly connected to the electrical service ground. Metal enclosures must be bonded together to ensure that they are all at the same electrical potential. Bonding can be achieved by using bonding jumpers or by using metal conduit and fittings that are designed to provide a continuous electrical path. Regular inspections and maintenance are also important for ensuring the safety and reliability of electrical systems in coolers. Electrical systems should be inspected regularly for signs of damage, corrosion, or moisture. Any damaged or corroded component should be replaced immediately. Electrical connections should be checked regularly to ensure that they are tight and secure. The cooler should be kept clean and dry to prevent moisture from accumulating and causing corrosion. By following these guidelines, you can ensure that the electrical system in your cooler is safe, reliable, and code compliant. Remember to always consult with a qualified electrician for any electrical work and to follow all applicable electrical codes and standards.